Example 4 on using or evaluating integrals where we use the integration by parts formula. Okay, so guys, this one is a simple one, but it's still a little tricky. So because in this case we don't see like a product of two functions, but there's no other way of actually evaluating this integral. There's no like a shortcut way. There's no like direct rule for us where we can just directly evaluate the integral of a log function like this, or I don't think we can even use the method of substitution. Guys, you can try and see if that works, but I doubt it that if we can use the method of substitution. So what is going to work here is again integration by parts. So there's one minor thing that we have to do in order for this to look like an candidate for integration by parts. So guys, we can rewrite this guy as integral of ln x times 1 dx, right? Because any quantity times 1 is the same quantity, it does not change the quantity. But by rewriting it like this, we can now see that it's the product of two quantities. Now here, this does not really tell me anything about like constants, but we are still like, at least it tells me what to do first in terms of like if I have a log function. So here I have a log function, so I'm going to treat log function as my f function, and then I will obviously treat that other constant function as my g function. Okay, so this is going to be my f and this is going to be my g in that order. So guys, now we just have to use the integration by parts formula, which is already listed up here. So let us go ahead and apply that. First, I have to just simply write the f, which is ln of x times integral of 1 dx. Just have to write that step, and then minus integral of f prime. Integral of f prime means that we have to do, there's an integral outside. We have to do the derivative of this function. We know the derivative of a log function is the inverse function 1 over x, right? And then times, guys, again, if you are not like, if you don't remember that, then you have to go back and look at the formulas, okay? And then we have times the integral of gx, which is 1 in this case dx, and of course you still have another dx because there's two integrals. With this integral I have this dx, and then this outer integral I have this another dx, okay? Now let us try to simplify things. It is not too difficult. So it is ln of x. Integral of a constant. Guys, we know integral of a constant is simply the constant times the x if we are integrating with respect to dx. So it is simply going to be times x, okay? And then minus integral, well here we have to do some extra work. There's 1 over x. We don't do anything with it. All we first do is we evaluate this integral. Again, this integral is simply integral of 1, integral of a constant 1 with respect to dx is simply going to be x, and don't forget there's a dx outside. Okay, this on this side, we like to write the algebraic function first, so we can just rearrange this and write it as x times ln of x. Okay, we got that part right. Guys, this guy, it simplifies so nicely, like x and x crosses out, so it is just 1 dx. Right, it simplifies nicely. And then when I simplify this further, we have x ln of x, and then minus integral of 1 dx. So integral of 1 is again x, and then there's a plus c. So here we have, guys, we have the integral for ln of x. So at first it seemed almost impossible to evaluate the integral of ln of x, but we can just like rewrite this as a product of 2 ln x times 1, and then again follow this method or this trick here that we have to choose, or we should choose the log function as the f function, and then we chose the constant function as a g function, use the integration by parts formula, and we were able to evaluate the integral of an ln of a log function. Okay, guys, this is example 4. Now there's one thing I want you to try on your own. I'm still going to show you more examples on integration by parts, but there's one thing I wanted you to try on your own. So guys, this is something that you should think about. Now we can, like, here you can see that all these examples there's a product of 2. So we cannot like generalize this that for any products, if we have product of 2 functions, we can always use the integration by part methods. It does not work for everything, okay? So I'm going to write these 2 examples here, and I would like you to see and verify for yourselves and convince yourselves that one of them can be done using the product rule, and the other one will be you'll be able to do the other one using the substitution and the product is not going to work for both these, even if both look like the product of two functions. Okay, so it will make more sense when I actually write them here. Guys, I have two examples. Example one is evaluate the integral of x squared minus x in parentheses times e to the power 2x minus 1 dx, and I want you to figure out which method you would use for this particular example, and like see why that method works and why doesn't the other method work, or maybe both work. So just go and try it and see. So which method works and how you can solve that one. And the second one is like this, integral of 2x minus 1, and then I have e to the power x squared minus x dx. So I want you to think about which method works for this one and which method works for that one. And since like you can see, this is also, both are products. This is product of two functions, this is also product of two functions. So one may say that it just qualifies for the integration by parts, and integration by parts should just get this done for us. But guys, that may not be true all the time, but I would like you to, think of this as, think of this as your homework, and you can think about this and see which method, whether it's substitution or, well, so far we learned substitution and integration by parts, so you don't have to like overthink about other methods yet, because it's only like those two that we have learned. So think about which method works for which one, and then while you try to do that, you will like kind of see why the other one does not work. Okay, the bottom line is, guys, how would one finally know like which method to use for which particular problem? It comes with experience, it comes with you practice. Okay, so guys, try that and try more examples on using the integration by parts, and I will see you with another example next time. Till then, guys, take care. See you next time.